My name is Dave McCrory, and this is Derek Collison, and we're going to present migrating your application to the Cloud Foundry platform, tips, tricks, and gotchas. We're going to, not only are we going to walk you through some slides, but if all goes well, we'll walk you through some live examples of some of the things we're talking about. So,
right. We can, just to set the tone, we're going to give a brief overview, but throughout looking through the demo and stuff, please interrupt us, ask any questions you want, and we can go as deep as you guys want to go.
Okay, so first a legal disclaimer. We have to say this so that our presentation doesn't cause the stock price to drop or any other crazy insanity like that. Essentially, obviously, this isn't a forward-looking statement or anything else. You can't judge this to affect our stock, et cetera, et cetera. Okay, so there are three layers to our view of what the cloud is. There's layer one, which is the infrastructure layer, layer two, which is the platform, and layer three, that's the software. And in the world of cloud, we have as a service attached to all of those. Specifically, Cloud Foundry is going to focus on the platform side. The infrastructure side, think of that as the classic vSphere, vCloud, vCenter combination, your storage, etc. You would push into that service machine images, OS images, things like that, the actual core components and resources of your infrastructure components. That's where the hardware portion of this comes in. Then there's traditional platform as a service. That would be pushing code and libraries into a platform, so attaching to services. And you're simply consuming resources. So infrastructure, those types of pieces are somewhat masked to you because you're simply pushing your code and libraries up, and the rest is being done for you. What Cloud Foundry is an application platform as a service. This is slightly different. This is focused on application instances and on services that those application instances consume. So think of it as I'm not focused on you sending me specifically just your code and libraries. I'm more focused on I want to spin up application instances, and I want them to talk to something like, say, a database, or use RabbitMQ or MongoDB or whatever it happens to be for data storage, or say Redis or something like that.
Does that make sense to everyone?
So new applications require a new approach, and so our vision is for Cloud Foundry to be able to live across all of the different cloud types. So you hear about private cloud, public cloud, personal clouds. We want Cloud Foundry to be spread everywhere. We want it to be a common platform that everyone can use. And that cloud application platform that we're focusing on provides all of the services that you see here, and we'll actually leverage and talk about some of those in just a minute. CloudFoundry.com itself is a public cloud. It's an instantiation of Cloud Foundry, the open source project that we've put into a data center that we operate. It runs on vCenter and vSphere under the covers. It supplies the ability to leverage runtimes and frameworks along with the services that encapsulate the Cloud Foundry open source. All of that's running on top of that infrastructure. And so if you sign up, get an account on CloudFoundry.com, you'll be running through the Cloud Foundry stack and ultimately on top of vCenter and vSphere.
Now, the design of Cloud Foundry itself doesn't necessitate that it runs on vCenter, vSphere. It can run on, a single VM like microcloud. It can run on bare hardware. It can run on AWS. But obviously, for our own public offering, we run it on what we think is the best IaaS out there. But the design of the system was specific that you can bolt it to any IaaS system.
So A traditional application deployment, think of a 3-tier app, right? You have a web layer, an app layer, and a database layer. It's common for enterprise applications out there. And traditionally, if you were doing this style of deployment and you were using vSphere, you would have a VM, maybe even a physical server, but commonly you'd have a VM for your database, you'd have another VM for your app, maybe you would bundle your app and the web tier together, maybe you wouldn't, maybe you would separate them. And these components would communicate between each other, and you would have 3 VMs that you manage that encapsulate what that application is. And so this is great, but there's still a lot of work to be done. You have to worry about upgrading each of the tiers individually. Scaling them becomes complicated. You have to reset up and change networks, alter your network topology, doing upgrades. It becomes a very somewhat brittle process unless you're very, very careful. Maybe provisioning the app initially might not be that incredibly hard, but it might be. And then trying to upgrade and scale it and update it gets to be really difficult. In fact, very difficult in a lot of cases. Apps are deployed somewhat differently on Cloud Foundry. On Cloud Foundry, you build your app, you type a single command, VMC push, and give your application a name, and it is deployed up to Cloud Foundry. And by deployed up to Cloud Foundry, I mean you have a running application instance that has all 3 of those tiers. The tiers are treated somewhat differently, but they all are running up on Cloud Foundry. It's a different paradigm in how you think about dealing with your applications. And
we're going to walk through a demo and actually show you what this kind of looks like in real life. We actually might do a different target and stuff depending on time.
Right, so targeting would be something that you can think of as being able to choose which Cloud Foundry cloud you want to talk to. And we have something that we call Micro Cloud Foundry. That's a single virtual machine that has an entire Cloud Foundry stack in it. We also have the CloudFoundry.com service that we operate that's a public cloud. We have people that have deployed the open source bits behind their firewall. And we also have several partner companies that have taken the CloudFoundry.code and created their own public clouds from those. So there are already out there many different targets that an individual could use to push their bits up into a Cloud Foundry instance.
And so one of the things that you guys might be very familiar with is the concept of multiple hypervisors, multiple infrastructure as a service. You know, provisioning a VM under vSphere and vCenter is very different than AWS versus Rackspace versus OpenStack versus CloudStack or whatever. And the same type of paradigm could exist at the PaaS level, but that really kind of defeats the purpose. And so if we can insulate all of that, what you'll see is that the commands that we do never change. The client tool never changes. So I can literally say BMC target somewhere else, let's say a microcloud, which I can spin up on my little error. And the commands that I will then push the app with are the exact same ones I push to cf.com, possibly with our partner AppFog now, who has an instance running. And we think that's really important. So it insulates you. Everything is consistent, not only between different IAS layers, but you can also think of VMC push to dev test. Make sure it runs right. Run it through all the QA. VMC target prod. VMC push to prod. We're good to go. Make sense?
Right. So literally, you could even behind your own firewall have a dev cloud, a test cloud, a production cloud. Literally one command to change. Everything else works the exact same way.
And so the way applications are actually accessed within Cloud Foundry is requests move through a load balance system, similar to what a lot of people would have set up. But they actually then move into the Cloud Foundry kernel and actually run through a dynamic router. And this router actually dynamically in real time understands where all your app instances are running. So think of all of these seats as potential places for you to sit, and you're the app. You can actually come in CloudFoundry.com, or Cloud Foundry, the kernel, and sit anywhere you want. And the router knows exactly where you are. Now, if all of a sudden you get sick or you die, and you come back and you sit over there, the router automatically knows that. If you want to run 10 of you, you'll pick the best seats you can find at the time, and the router knows about all of those as well. And so those requests are coming in, they're being, distributed through that router, who again in real time keeps a distributed state of where everybody is, and you can run as many of those routers as you want as well.
So don't think of the router, or in our case, what we're talking about when we refer to a load balancer as a piece of, say, Cisco gear or something else out in your data center. This is a logical router in software, and by router we're talking about, think more of a logical connection point dealing with routes so that we can dynamically spin up instances and do things like that versus trying to talk back to the physical network equipment and make it aware.
Right.
That would get really messy really fast.
Now that being said, physical load balancers can exist in front of multiple software routers that we actually run, and that works fine. To Dave's point, though, is you don't actually have to upstream any information into the hardware load balancers for Cloud Foundry to work. And just kind of give you guys a little bit of basis, our routers right now run at about 4,000 or 5,000 requests a second. But because we can actually scale and run as many of these as you want, and by the way the system's built, you don't have to bring the system down, start a new router with a new configuration, bring everything back up. You just start a new one. It automatically joins itself into the system, and the system is built to tolerate failure and self-heal itself all the time. And so now if we run 5 of these, essentially we can handle all of Twitter.com's traffic, at least maybe a couple months ago. We might have to run 10. And so the system gives you a lot of flexibility all the way down from a microcloud, which is what Dave was talking about, all the way up to the largest installations that we think people might want to run. So how are apps scaled? And this is the concept Dave was talking about app instances. And the interesting thing about the way the system works is that scaling an app to have multiple instances is just deploying another app, so to speak, in terms of what the kernel's looking at. It literally has someone who walks in the room, and I just say, find a seat wherever you want, sit down, and you're good to go. And what the system's actually doing underneath is that the cloud controller piece, it actually requests a seat and says, hey, I need a seat for someone to sit in. And someone raises their hand and says, great, you can sit there. And once you sit down, you go, okay, I'm nice and comfy, I think I'm ready to go. And you kind of signal to our system internally through what we call the DEA, which is a droplet execution agent, or Dave says dynamic execution agent. What it really means is engineers shouldn't name things, so that's all you need to know. But it essentially signals to the system that the app is ready for traffic. And that signal is a message that actually all the routers actually pick up on. And then they'll bind that URL namespace to the IP and port wherever you're running. Consequently, if you want to scale back, let's say the peak's over and you want to bring things back, the same thing happens. They go away, the router dynamically figures it out and understands. Yes?
So is there auto-scaling within the infrastructure, or as a deployer, do I need to know how many instances I want to fire up?
We don't do, now auto-scaling, the question was, do we have auto-scaling within the infrastructure? Which is a good point in terms of the decoupling between the kernel itself and the orchestration or provisioning layer that actually operates on it. So for example, the provisioning layer when I run microcloud is me. I press the start button. Within CF.com, we have a lot of technology around how we actually spin these things up and move them around. We don't actually auto-scale. This was a lesson that we learned pretty well within Google. A lot of the founders of the team came from Google. What we do, though, is monitor everything. So every single component in the kernel has a HTTP port that it spins up on the fly, that it does random username, password authentication on, that if you ping, it dumps every single thing about what's going on in the system. And so you can imagine dashboards and monitoring agents to actually watch the capacity of the router pool and say, hey, you might be hitting a threshold here where you might want to add one in.
And it's very easy, though, to add it in. In other words, if you turn on a router, if you turn on a DEA or any of those components, they attach to a message bus, and they're immediately taken advantage of. And that's an automatic process. So, no, it's not dynamic auto-scaling as far as it doesn't scale itself automatically, but all you have to do is, if you're talking about the components of Cloud Foundry, you just need to turn them on and they automatically are taken advantage of. And applications, if you want the application to scale, it's a single command to scale it, and it happens in seconds. And by seconds, we mean...
Well, you'll see. I mean, and to Dave's point is you have the choice, both in terms of your apps internally and the infrastructure. And so I think the takeaway point is that we monitor everything and that's available. You can hook everything under the sun and watch it. And what we do is we have alerts and thresholds that we react to and actually will deploy more components. If you want to write an orchestration layer that actually spins up routers based on something that they see on their own, you can do that. And for example, we also have several auto-scale demos. It's a tough one. Everyone says, oh, you should auto-scale everything. And I think in the simplistic case, you can do that. I usually like simple things, but in this case, I also know the semantics of the app and the services that you're using is really important. So we allow you to do it. We haven't figured out if we actually want to offer a service that you can just kind of click and say, wow, that's good.
Right, because ultimately what you'll end up doing is moving your bottleneck somewhere else. Whatever you scale, there's going to be something else that moves around that's going to then become the bottleneck. Not knowing which thing has scaled immediately because no one actually did it, and then having this new problem appear in your infrastructure because the system reconfigured itself, that's a tough problem to deal with. Even with management tools, it's a tough problem.
So now how are apps updated on Cloud Foundry? There's essentially one method of quote-unquote updating an app. And for the people who run production systems, as soon as I tell you how it works, you'll say, ooh, that's wrong. But I'll explain why we did it that way and actually what we actually can do on the production side. When you update an app, essentially, let's say Dave's the original app and I'm the new app. I essentially come in and you say VMC update. I go into the system, it wraps me all up, makes sure I'm ready to go. It shoots Dave in the head and tells me to start. So depending on how long your app takes to start up, let's say it takes 3 seconds, there'll be a 3-second window where there might not be anything running. And everyone's like, wow, that's not good.
Just so you know, I'm shot in the head repeatedly on a daily basis.
He shoots me back in the head as well. We'll reverse it the next example. The reason that we did that was we felt, production rollouts and versioning and things are something that individual enterprises and organizations take very keenly to, and they actually have very prescriptive ways of the way they want to do that. And so when we did a production rollout of the www site for Cloud Foundry, we obviously wouldn't do a VMC update. But what's neat about the system is that, and now I'm the original www, we actually will say VMC push, meaning create a whole new app called www2 and map it to www some weird key or test or whatever like that. Dave comes up as a new app. We can QA it. We can look at it. We can then VMC target production, do the exact same thing. So now in production, there's www, that's me, and I'm fielding all the traffic. And then there's Dave sitting over there. Now he's using the production database, but no one really knows where he is, his address. But we can QA him once more and say, okay, he looks good. Then what you do is you say, map that app to the same URL namespace as me. So let's say there's 4 of me and there's 1 of him, right? So now all of a sudden he's taking on 20% of the load. And you kind of sit back and make sure everything just doesn't fall apart. Once you say, ooh, it looks good, you crank him up to 5 instances. So now we're both running, right? And then you simply look at me and you say, guess what? I'm going to unmap you from the URL namespace. So no requests are coming to me. Yet I'm running, which means that your rollback scenario, your oh crap moment, is you map me right back and take, oh, see, I did it again. I killed -9 a day. So we believe that the flexibility allows you guys to actually do exactly what you want to do in terms of a production rollout. And we'll demonstrate what I mean by that on this.
Right. So the idea is that we let you choose what operationally is best for your app upgrade scenarios. Realize the more you build the apps to take advantage of how Cloud Foundry behaves, the more you can take advantage of having apps that are constantly available and are really impervious to virtually any kind of single failure that happens inside of the infrastructure. The downside is that you do have to apply some logic to your applications. If you just push that 3-tier app up in and of itself and it makes assumptions, say it decides to write to the local file system, for example, with Cloud Foundry. If you're writing to the local file system, that turns out to be really bad because we're killing these DEAs potentially, and if you've written something to the file system there, it's not there anymore. So it's not nirvana. It's not under all circumstances all code can just magically work. In many cases it can, but if you don't follow good practices in the code, you can still get bitten. So the idea is if you were storing something in that local file system, you should now either be storing it in a networked file system, or you should be storing that data in something like Redis or another key value store or something like that, so that you externalize that stateful data. So that would be something that would be a caveat. Your app would still run. It's just you could end up losing data.
Yeah, and the key point that Dave's pointing out is that a lot of PaaS systems might actually lock you down and say you absolutely can't do a lot of things. And the view of the world that we took was we want normal apps, normal modern apps to be able to run kind of unimpeded. So if they want to use a MySQL database, let them do that. If they want to write to the file system, they can. But as Dave pointed out, there's certain contracts that we have with the apps. Like, for example, that the file system is read-write, but it's ephemeral, meaning it can go away. And so one of the things, and we'll get into this a little bit more, is that any type of state that you want to share and persist between app instances, meaning yourself if you're a singleton, because you might go down and come back up, should be through a service. Okay, so we'll switch over to doing a demo. We can go as deep as you want to go, and any questions that you guys have, please stop us and just interrupt us. So the app that I wrote a little demo in the last day and a half or so, and I tried to kind of pick a lot of the stickiness issues that we would have and something that's complex enough. And I believe we have permission to open source this, so I'm going to actually open source it and tweet out the URL once we get all the permissions done. But essentially I wrote a little chat demo, and it's not necessarily a chat back and forth, but it's people can actually be inside of a chat system, and then there's admins, and the admins can talk back and forth to the people, or like say a help desk. I wrote the application in Node, so if I actually want to fire it up right here.
So, and just as a little bit of background, if you haven't heard what Node is basically a language that's built around JavaScript, and it uses an engine that was open sourced and built by Google called V8, and V8 is actually something that powers Chrome as well. But Node leverages the incredibly efficient engine that is V8, which, like I said, you can actually download V8, you can download Node, you can do all of the same things that we're doing here yourself.
Right. And the app is a medium complexity. The reason I picked Node is that, for example, the app.js, if this is essentially right here, these lines here is how you actually set up a HTTP server. And when you actually want to listen on something, that's how you do it. So, for example, for me to respond to a /index call is just result render index. So, fairly straightforward, fairly simple for the demo. We can not have to worry about building, HTTP endpoint web server. So, there's a little thing called Express built on Node. Makes it really simple. It's kind of like Sinatra, if anyone here has heard of that.
Be like Rails.
Right. So essentially,
boiled down.
That's literally sets the server up. Now, down here is something called sock.js. And sock.js is one of the RabbitMQ guys actually wrote a WebSocket layer called sock.js that actually can do fallback. Okay? And so this is a WebSocket type app. And so as you're typing things into the chat window, which I'll show you in a second, things are flying back and forth real time. Now, CloudFoundry.com doesn't truly support WebSockets. No PaaS that I know of does yet. And we're trying to figure out how we want to do that. But we've tried to pick some modern sticky type issues, if that makes sense. And so in this thing, if I actually go ahead and join, hopefully you can see that. It says, oh, you joined. The admin console over the side said, oh, Derek joined. I can say, Dave will join down here. And so this is a typical single server. Sock.js is handling the messages. I can say hello to everyone, so this will be broadcast to both. And then I can say, hey, Dave, you can't do that. All right, and that only goes to Dave. Make sense? Nothing really complicated there. And if I kill this guy, these guys will tell you that they're disconnected. They detect that, and then they're going to try to figure out if they can reconnect, and eventually they're going to fail. So now all of a sudden, oh snap, we lost our connection to the servers. You can then restart it. You have to refresh all these guys, but it comes back. Now within the system, even as it is today, I knew it was going to be a cloud app. So I knew that connectivity between a single instance of the back end, again, behind those routers, if there's more than one, could be sporadic, right? And that's one of the things about design for failure. Assume things are going to fail. And so I put in a little hook that says, hey, if you actually get disconnected, it might not mean that the world has ended yet. So maybe try to reconnect and see if somebody's there. So with a single instance, that means I can bring it down and bring it back up within a certain time window. And then within Cloud Foundry, if things are moving around, the system keeps working. So I'll show you that real quick. So I killed it. I bring it back up. And if you go back here, you'll see this as disconnected and it reconnects itself. And I can still tell Dave hi. Make sense? Nothing crazy, super complex about it. But now what we're going to try to do is we're going to try to say, okay, well, how do we do this with Cloud Foundry? And how do we actually scale this system up? And that'll get a little bit stickier. So the first thing is that within this guy, most of the frameworks within Cloud Foundry, frameworks meaning things like, Spring and Lift and Grails and Ruby on Rails and such, we automatically can wire those up to actually do the right thing in terms of a port. So in CloudFoundry.com, one of the things you can't do is say, great, I got port 80, I'm good to go. We actually tell you what port on the fly that you're supposed to use, and it's an ephemeral port that we actually scan and have a range of. So when you actually come up, we're actually telling you start up on this port. But we have to be framework aware to do that. Another reason I picked Node is that Node is not framework aware of this. So this is actually the hard version. But Ruby on Rails, Spring and all, it just automatically happens. So when you deploy your travel app or things like that, it just automatically works. This actually shows you underneath the covers, though, what I did to say, I want my app to be able to run locally, but then if I push it into the cloud, I want it to run also there. And so there's an environment wrapping, environment variables that both define everything about your app that Cloud Foundry knows about and all the services. And the two that I'm looking at there are VCAP, app host, and port. And so essentially I say if these are defined, use them. Otherwise, use localhost and 3001.
So that's how the app can just check to see if it's on Cloud Foundry or not.
Right.
That's the short version.
And so on here, I'm going to run another app of my app, but I'm going to put it on port 3002. And I did that by actually defining that environment variable. So now over here I can say 3002, Dave, right? Welcome, Dave. But over there it said Dave left the system. And the reason is that these two app instances can't talk to each other. So remember when we talked, when Dave was talking about, writing through the file system, but if you want to share any state between stuff, that's what a service is for. So in this case, you would actually want to bolt in, a publish subscribe messaging system like RabbitMQ. Redis also has a PubSubsystem. And I actually put in Redis into this system. And the reason I did it is as we open source this code, you can run it on CloudFoundry.com and MicroCloud Foundry. MicroCloud Foundry will be adding Rabbit soon, and CloudFoundry.com proper already has Rabbit in it, but that's the reason. But we need to bolt these guys together, right? And if you've noticed, if you've been paying attention, which is hard because it's early in the morning, when I start this guy up, it says Redis connection to localhost failed. And so what's going on there is that I've already put the code in to say, okay, I get this. I'm going to have all of the instances talk through a Redis instance to do pub/sub back and forth so that when Dave posts a message over here, the system over here will see it and translate that to all the admin clients that are connected to it. Does that make sense? Yes? No? Too early? So I'm going to fire up a Redis server. I will kill the first one, and I'm going to restart him. And so now it doesn't say anything about, hey, I can't find any Redis guy. I'll start this guy, and this guy's on the second port. And we're going to reload all of these. And so now I'm on 3001. Dave's on 3002. But if you notice, the admin guy saw that Dave joined. So we already know the Redis stuff and the PubSub stuff is kind of working.
You're not going to shoot me in the head again, are you?
No. That all make sense? So essentially, the two things we've done here is we've made sure that if Cloud Foundry is determining the port that we're going to bind to, we do the right thing. And again, the take-home point is that we actually do all the heavy lifting for most frameworks for you. This is specifically because of the tips and tricks. If your framework doesn't support it, like Node doesn't right now, you actually need to do that on your own. The other one is we've started talking about a simple app that has clients and admins, and now all of a sudden we're thinking about scaling it out, and we automatically had a problem because those two couldn't talk to each other. Right? And we figured out how we want to do that both locally in terms of running a local Redis setup, but also mapping that to cf.com. So this is the code. We use a couple packages, but the app.js is about 5,900 bytes. I'm not sure how many lines it is. 259 lines of code. We use a couple of app views that just do some pretty HTML, but pretty basic stuff. Nothing crazy, there. We use jQuery to map stuff in on the fly as you type stuff in. The messages get sent to the client. Inside your web browser, we suck it in. So let's actually go ahead and then say, we want to actually put this on Cloud Foundry. So I'm actually connected to cloudfoundry.com. So I have an account on there. And I'm going to go ahead and do VMC push. And we're going to do the version where I'm going to answer all the questions. But this is essentially, we're going to go ahead and in one iterative step, we're going to go ahead and create the application footprint, push the bits up into the system, package the system up for running, deploy it to one of the seats, get comfy in the seat, raise my hand, say, okay, I think I'm good to go. The router's going to bind that URL. And then if we hit it inside of our web browser, we can find it. Make sense? So this is, again, the iterative. So it says, do you want to deploy from the directory? I say yes. Let's call it VMwchat. So now this is the URL that it's automatically binding to. That's based on the target. So if I would have VMC targeted my micro Cloud Foundry that's running on my laptop, it would have had vmw_chat derek's error.cloudfoundry.me, I think. Make sense? You can pick whatever you want, and the system itself is technically designed to support external URLs. When we launched, a company called Function Source that does Ajax JavaScript type blog actually launched on us on day one, and they're actually at functionsource.com. Most of the URLs, though, within especially private setups, will be wildcarded DNS, so your app name will be first, and it'll be whatever your target is. So I say, yep, that sounds great. Detected a Node app, yes. 64 makes fine. Right now I'm going to say no. I'm not going to bind any services.
At least you can see this is live.
Yeah. Those are always fun.
By the way, to totally obliterate your app, you can type VMC delete and the app name, and it will truly remove your app entirely. You can also do update, and we have several other fairly sophisticated commands. You can not only provision services, so you can provision that Redis or that MySQL service in a single command. So you can do VMC Create Service space MySQL, and in probably about 3 seconds, something like that, you'll have a MySQL instance up and available to you that you can attach to and start using.
All right, I'm ready now. My Emacs buffer put a file in there that VMC didn't like.
Still didn't like it. The other, well, we'll see. The other interesting thing is you can also bind the apps. There are two steps when you use services.
Okay.
You can, the steps are to provision the service, and then you have to bind it to the specific application. So services are attached to accounts.
So that did everything right there. So it's now running after my failed attempt at my editing buffer. So if we go to vmwchat.cloudfoundry.com,
and they should be able to, if they want to fire up a browser,
yep.
attach to that as well.
Yeah, you can actually go and attach to it as well.
So if you have your laptop and you want to hit that URL, you can see it's live right now, and if we take it down at the end, you'll see it's gone.
And so I'll connect all of these guys to the one now running there. And so as you can see, the same thing we were doing locally is actually working. But remember, we have one instance. And so now if I actually fire up 2 instances, we're going to be broken again. We're going to have that thing where we can't talk to each other. Does that make sense? The other thing you have to realize too is that the WebSocket protocol is stateful. HTTP is not stateful. And so if I have 3 instances and I'm actually talking to one, I want to keep talking to that same one. And so with WebSockets and with a lot of things within Spring frameworks, we have the concept of sticky sessions. And sticky sessions means that once I actually hook up and bind to a certain instance of the app, I want to kind of keep talking to them as long as I can and do the right thing there. And so the Socks.js stuff actually does that. It actually sets the correct cookie that our system can actually rewrite on the fly. So CloudFoundry.com actually understands sticky sessions at a protocol layer, and those dynamic routers actually do the right thing, both inbound and outbound on all your traffic. And so right now I'm bound only to that one. And as you can see, it says connected to 7589. I don't know if you can see that. Let me see if I can make that bigger. Now all of a sudden there's a whole bunch of people starting to join. You can kind of see it a little bit now. Let's see, it says, oh snap, we lost our connection. It says it's running. Now what if I wanted to say instances of VMW chat +1? So I want to add 1. Well, that was pretty quick. So now we have 2 instances running. The issue, though, is that I'm still connected to 55438. You guys might connect to something else, and we're not going to be able to talk. So if you guys are joining in or not, that actually is not going to work. So we've solved the problem with Redis, right? And we know that Redis works because we did it locally. So how do we actually do that within the app itself? So I can say VMC services. And this essentially lists all the global services that are available in the target. So within CloudFoundry.com, you can see we have Mongo and MySQL and Postgres now, which is on our the vFabric data director. RabbitMQ, which the gentleman that started that is in the front row, Alexis, and Redis. And so we're going to use Redis right now because that's what we did locally to actually make this work. So I'm going to say VMC Create Service Redis minus bind to VMW.
So this is taking those 2 steps I was talking about a couple of minutes ago and putting them into a single command. So it's going to provision it and bind it to the app in 1 step.
And actually stop your app and restart it.
That's right.
So it's going to do the whole thing. So now, in one fell swoop, it's going to go ahead, creates a service, it gives it a random, well actually I guess I can, yeah. And then it binds it. It actually realizes that your application is running, so it stages it, brings it down, and restarts it. So now as I actually join in, I can see that I'm connected to 15437. But you guys might be connected to something totally different, right? Because we have 2 instances running. Does that make sense? So let's do, this is our little +1. Let's say +10 more. Let's say +20. Now as we're doing that, what's going to happen is that as all these nodes come in, normally you don't want your users to care, but for the demo, we actually, those systems are coming online and they announce themselves internally. And so what we do is we actually print out as these things actually come up and down. Now I just scaled it all the way back down to 1. All right, and so the system is automatically adapting, it's sharing state, these things are moving all around. Let's, again, consider this to be the DEA pool, in other words, where everything can run. And let's say we know that 1's not enough. We're starting to get more traffic. And you can see from this thing, I can say, all right, I want to do 21 for a total of 22 instances. That's pretty fast. They're all running. And so if I actually say VMC instances of VMW chat and not give it a number, it actually will list out all of them, show the state, show everything that's going on with them. And again, if you're on the The admin, by the way, it's a demo, so you're free to play with it. It's admin. But you can actually, if you just type into the admin console, that's a broadcast, goes to everybody. And then if I want to pick someone, you do tweet style at whatever their name is, and you can actually just talk to them. So hopefully you guys got a sense of not my Emacs buffer withstanding and putting a file that was causing the push to not work. How easy the system is to use, to interoperate with, to scale up, but also in terms of taking an app and actually not fundamentally changing it, but understanding some of the things in terms of the cloud stuff. So the fact that SockJS can actually degrade out of WebSockets into something else. This uses like an iframe event source. That CloudFoundry.com actually does understand sticky sessions, and if you want to utilize those for any state transition, like Spring sessions in the Spring framework, in our case, because of the WebSocket, it's you're connected to a certain server, and that server knows about user Dave or user Derek. To do that, we know that as we scale up instances, we have to actually share state between those. And the easy answer to that is always a service. So again, you can actually write to the file system, you can do all kinds of stuff, but if you actually want to share state, you go back and forth with a service. And in this case, we use the PubSubsystem under Redis. Rabbit is actually the choice, and as soon as Micro Cloud Foundry comes out with Rabbit, I'll flip the demo to use that because that's the right choice there. And then lastly, we realized that even if there's only a single instance, we have to assume that things might go up and down. Now, we've got about 15 minutes, so we can definitely ask questions, or I can actually do an update and do that rolling production update if you guys want to see that as well. Yes?
Question regarding the database scaling. You showed how the routers can scale, app instances can scale. How do you scale the database service?
The services are presented in a fashion that is orthogonal to the CF.com runtime. So within, or CF, the kernel, but CF.com, for example, we run our own services. And when you saw this list of right where it says that's what's available, and I have one of my Redis things provisioned. Those things are set up by us, they're run by us, it's a free economic, it's a free tier, freemium tier right now. But you can imagine that those services would actually scale and be presented under a different label. So you might say high perf MySQL, or you might say DR MySQL. And so when you bind to that service, you're doing MySQL, but underneath, the service provider specifically for that service actually does higher performance, master-slave replication, and does DR type stuff. And so the way we believe those will scale is the service themselves will do the right thing, or they'll present you a different option to bind to. It might cost you more money.
This is one of the areas where we think that other public cloud providers, as well as when people implement this behind their firewall, this is where the real differentiation occurs. You might pay a premium for an ultra high-end system for, say, Postgres that, is really operating on hardware that's populated with SSD drives and 10 gigabit Ethernet and, is clustered. So that would cost more money, but that would be a differentiating service compared to, say, a lower cost provider that chooses to just provide you with MySQL and it's on purely commodity based hardware. So there are all sorts of different pieces. The other thing is just being able to drop it into your existing environment and attach to your current databases as is. So we're looking at what we can do as far as providing more capabilities in the services layer, but at least right now we think we have a pretty good story on making it easy to understand both for ops and the developers.
And in addition to what Dave was saying, the OSS bits, the open source bits, actually come with a reference architecture around how you can do single tenant scale out. And what I mean by that is let's say for Redis, for example, every time I say I want a Redis service, the system has several options. It can run against an existing service and run it in multi-tenant mode, meaning multiple users use the same, let's say, Oracle database. You can actually spin one up on the fly, provision on the fly and tear it down. And on Redis, that's actually what we do. But there's actually, in the OSS bits, there's actually a reference architecture around a gateway node that understands, a gateway that understands all the nodes behind it. And similar to the architecture around Cloud Foundry where we said just add another seat to the room, we don't have to do anything special. And if someone walks in, they see the seat, they can sit in it. The same thing happens on the services side with that reference architecture. So you can actually just spin up another VM that announces itself as, hey, I can spin up Redis servers for you. and it attaches itself to the gateway. Now, we believe, as Dave said, that service providers themselves will differentiate and do very, very exotic things to actually make the right experience for their users. But we didn't totally drop you off the end of the earth. There is actually a reference architecture for how you would actually do that. It also works on multi-tenant. So in CF.com, our MySQL database is a single server on a VM that's multi-tenant, meaning lots of users, and as that gets filled up, we just crank out another VM that does the same thing and automatically joins the system. Yes?
Going back to what you were saying before about the idea of having, for example, a highly available Postgres server or a disaster recovery.
Sure.
Is there anything in Cloud Foundry that actually helps me either manage that or me as the user just saying, you know what, for my app, I no longer need the regular Postgres.
Right.
I want the highly available.
Sure. We do several things within the Services Gateway API and within the system itself to allow you to tag services with certain tags that you can actually then take react to. And then CloudFoundry.com obviously has an identity system, and you can actually configure the system to say when, and I'll flip it this time. So when Derek comes in and I say VMC services, I get the crappy free MySQL database. If it goes away, don't worry about it. When Dave comes in, he gets this is going to cost you $5,000 a month, but you have access to this. And so when he actually goes to bind to a database, he only has one choice. Does that make sense? And so I think there's more to do there, especially as we push into a private enterprise version of Cloud Foundry. But we've got some of the first steps in terms of what we're trying to do there. So we have the concepts of limiting scope of services in terms of the advertisements. You know, I can't see the stuff that Dave can see and such, and I will probably extend that.
Right, there are already some quotas in the system that we put around users. So you have on cloudfoundry.com, while it's free, it's a 2 gigabyte RAM quota, for example. So you can do whatever you want as long as it's within 2 gigs of memory. So we do have, and we're going to continue to add that those types of things. And if you need more than 2 gigs, then you'd have to create another account.
Any other questions?
Any plans for supporting the .NET framework?
The
we want to support it at some point.
technically, it is very, very straightforward technically to do so. Essentially, it's a DEA that runs on a Windows VM, and those DEAs, they understand the concept of what they can run and what they can't. So in CF.com, they're all homogeneous, so they all say, I can run Java, Ruby, Node, whatever you want. And so when I ask for request, the analogy again is I need a seat, I need a red seat. And only the ones that have red seats actually respond. And so you can easily envision a system where the DEA is running on a Windows machine, and a request comes saying, I need a green seat. And the only ones that can respond to that are the ones that are running .NET. So we've thought a lot about it. Technically and architecturally, it's kind of already built into the plan in terms of differing platforms that actually change the underlying OS and VM underneath the DEAs. We don't have any plans that we can comment on right now.
Specifically for the Spring framework, I wonder how basically the dependency injection works for any of the services. So do you basically, are you forced to do a lookup, or how does exactly that work?
And so if, for example, I know you said about the Spring framework, but essentially the basic building blocks is that we internally don't have framework bits, but we understand frameworks. And so if you saw when we did the VMC push, it printed a line saying staging your app. The application bits that you actually send in to us, and you don't send everything, by the way, we actually do some intelligent differential tricks there. But the app that you send to us isn't the app that we run. And so we run it through a 2-part stager right now. The first part whips through and actually stages your application in general sense to actually run. So for example, with Spring, we bundle in TC server, and we make sure that that's all ready to go and it can actually does the right, context route and all those fun things. The second part stager is for services. And so what the stager does is it says, I've got this framework and I have this type of service. So in your case, I have Spring and I have a database. Can I do anything about that? And in the case of Spring and a database and Rails in a database and such, the answer is yes. And then we actually run specific code that's framework specific to actually inject that in there. So you don't have to do the lookups. So Ramnivas, who heads up our Spring efforts underneath of Cloud Foundry, he did some pretty sophisticated stuff in terms of he injects in different profiles and automatically sets the profile if the app is running inside of Cloud Foundry. So in other words, you know the trick where I said the VCAP app host or 3001, or localhost? He does a very, very sophisticated version of that around different profiles. One is which is a cloud profile that the stager actually builds for you. And then the runtime, when you actually run, the system actually realizes that it's actually running inside of Cloud Foundry and picks the cloud profile, which has all your database credentials, pooling constructs, all that other fun stuff. Yeah, in Rails, it's a lot simpler. We just rewrite the database.yaml file. But the key point is that that second part stager looks at the framework and the service and figures out if there's anything it can do there.
Right, the easiest path to take with Spring would be to use the 3.1 profiles. I think it's all baked into that right now, if that helps.
I know it's early, but any other questions? Sure.
What do you envision the developer experience being like as Cloud Foundry grows? I know you put tooling Spring. How do you see developers on their day-to-day life working on the Cloud Foundry platform?
Right. The question is, how do we see developers working on the Cloud Foundry platform day to day? And I'll be honest with you. Originally, when the system was architected and built, it was more projected as a deployment system. And that was a lot of my thought around you'll develop locally, kind of like I showed you the way I do things. And then you'll deploy into the cloud. And you'll need some basic tools in case something's off. But essentially, you do all your heavy lifting debugging here. The simple answer to where the system went was I was wrong in a big way. And so as we started adding services, especially with, and Dave talks at 10 on Micro Cloud Foundry, that I can run a whole Micro Cloud Foundry with all these services already set up for me right here on my laptop, we immediately had some of the lead developers actually on the system itself saying, I need to write a sample app, but I'm not going to set this thing up anymore. I'm just going to use the one that we have running. That immediately put us into more of a development mode. And so I just tried to show you this concept of BMC logs. It'll actually put all the logs together and send them out. You can look at any single file within the system. So I can say, I want to see this with what's in app, and oh, there's my app.js file, which is the same thing we were just loading. This is a good first step. We have to do a lot more. And the team is working really hard internally to figure out what that looks like. And what are the tools that, when you are developing locally, that we could extend to you're actually developing and deploying in cloudfoundry.com or any target, even if it's on your own box. So expect to see a lot more to come. We're going to do that for both applications and development and also services. So tool sets that you use to actually interoperate with your services and things. Because right now the services are a black box too. So we can automatically provision the schema and set things up on your database. But if you say, no, I want my PHP admin to point right into there and I can twiddle stuff on my own, currently that's not possible. But we realize that we have to actually respond to that. And we've known that for a while. We just want to make sure that the experience is both holistic and complete and does not have a leaky abstraction model around it and is really, really suited well. Any other questions? Yes?
Anything that performance management of the application?
So, for example, I can say VMC, I think it's stats, BMW chat. And I've got 100 of these running, so it'll take a second. But if you look at what it does, is it'll actually give you the instance. So if I scale it down to 1, we'd only see 1. The number of cores that the underlying DEA is giving to the app that's running, your memory and the limits, your CPU and the limits, and your uptime. And so through the API, through cloudfoundry.com, you can actually monitor your own apps and watch them for certain behavior. We also watch your apps for certain behavior. So we allow you to do things like fork threads and spawn processes and do all kinds of fun stuff within limit. The limits are pretty generous, but we actually do enforce limits. And if you actually exceed those limits, we'll actually shoot you in the head. So we'll take you out. Now, immediately the system will say, wait a minute, Dave's supposed to be running. Where did he go? And it'll restart it. So if your app slowly is leaking memory and it goes over the threshold, it'll go away and come right back up and keep doing this. So we have this tool. We're looking at some other tools to actually aggregate this information that might be very useful to some developers. And so we're also pushing hard on that. Yes.
So what's missing from your perspective for enterprises to use this?
There's, from the outside looking in, what's missing is some of the enterprise features of how do we actually mold in services that we don't control at all, like an Oracle database that's on site. How do we actually allow external provisioning of services that aren't understood internal to the system, but actually aren't controlled? You saw when we said VMC Create Service, we did that. Active Directory or LDAP-based identification, which right now Foundrycom has its own sense of what that is. But we do have something internal called Project Bento, and that is an enterprise version of a private PaaS of Cloud Foundry that you can set up and run in VMware supports. And that'll be sometime in the first half of 2012. And so all of those things that I've talked about, we've already addressed those, and we're uncovering more things that we need to do to make sure that both the lens of the developer, the lens of the service provider, meaning like I own the Oracle database, and then the lens of the infrastructure as a service. I'm the one that's going to give you the resources to run your own little micro cloud internally or something like that. We have to really kind of think of all three of those fairly well thought out and complete. So, and we've been in the process of that for some time now.
We have to wrap it up.
Okay. Well, thank you. I appreciate it, and we'll hang around outside if there's any other questions.